Hello, so this is experiment number, your practical number 5. So here what we will do is, we have taken a practical from your last assignment, it is LDR. Okay, it is, we have used a bulb with an LDR, right? So the value of LDR and the status of the bulb will be now displayed in this LCD. So already the connection of LCD and the circuit for relay, LDR and bulb is already given in our last experiments or practicals. So here just we have added two practicals together, that is the LCD and the LDR. Now the connections I will just briefly explain you. All the components here are taken from the component list. These are LCD, Arduino, a bulb, a power supply, a potentiometer, two resistance, a LDR and a relay. Okay, the connections for this relay and bulb is already you have already done in our last experiment. Now I will show you how I have connected the LCD. So I will zoom it now. You see, if I zoom it, you will see there are total 16 pins. Okay, 16 pins. Out of this, DB0 to DB7, these are the data pins. That means if you are going to write something into the LDR or read something from the LDR, these data lines will be used. And above that, some other pins such as ground, VCC, V0, reset, read write, enable pin, okay, LED high, these are for backlight, means to light up the LCD we use these two terminals. So if we don't use this terminal, we'll see the reading but it will be dimmed, it will not lighted from backside, then backlight will be off. So these are the data pins, these are for the backlight. This is the enable pin which enables you to display something here. Read write, either you are using as read or write. So for time being what we are doing, we are grounding this because we are not going to write from the LCD but we are going to read from the Arduino, right? And V0 is connected to a potentiometer. I will show you, this is connected to a potentiometer. Why it is connected? It will give you the brightness of the LCD. You can change the brightness by this potentiometer. If you don't connect, then also it will be alright, but if you connect, it is good. And another two pins are there, ground and VCC. Ground will be connected to ground and VCC will be connected to 5 volt. Now how I have written the code is, you have to see here. Rest of the coding will be same as that we have done in relay, LDR and bulb programming, but here we have included this LCD. Now for LCD we don't have some certain, these are not built-in programs, lcd.begin. okay, so for certain components like LCD, like DTH, temperature and humidity sensor, and some sorts of sensors and display devices, you need some header file. So here we have used this header file, okay, liquidcrystal.h, and for this we need a library, and that library we can download it, okay, or it's already there in some Arduino files, okay. So if it is not available, certain library files, we can download that library file and we have to paste it in the library of Arduino, okay. Now here in this statement, liquid crystal LCD 12 11 5 4 3 2, here this last 4 pins, that means here 2 3 4 5, that means your Arduino, these 4 pins 5 4 3 2 are connected to the higher data pins, that is D5 D6 D4 D5 D6 D7. Okay, if we are using 8-bit data, then here we have to write 8 pins. Okay, since we are using only 4 data pins, so we are using 5 4 3 2, that means these 4 data pins will be connected to 5 4 3 2 of the Arduino board. And this 12 and 11 means 12 is the RS, that is reset, and 11 is the enable pin. That means the enable pin will be connected to pin number 11, this one, and 12, that is this RS will be connected to 12. This is how the LCD will be connected. It is explained in this statement itself. The data pins and the RS and the enable pin. Now to begin with, we know that this LCD is a 16x2 LCD, right? So what we will do, we will begin this LCD by writing this statement LCD.begin 16,2. This is the initialization of the LCD. As we are initializing the input and output mode of the Arduino pins, similarly we will initialize the LCD.begin, and also the serial monitor is initialized. Now we will set the cursor at LCD set cursor 0.0, 0,0. That means the first position. Okay. And what will print there? Sensor, and it will read the value from A0 here. The LDR value will be read, and this value will be sent to the LCD. How? We are reading LCD.print analog read A0, means whatever value is read at analog pin A0 will be displayed over in this LCD. We'll wait for 1 second. Then it will clear the LCD. Okay, you see that again your serial.print, this one is for your serial monitor, serial.println. Then again we will set cursor at 2,1. 2,1 means at this position. 2,1, that means column 2 and row number 1. If analog read, we will see if the value here at A0 is greater than 500. That means we have to glow the LED, right? That means it is dark. So we will put the relay to low, which will close the circuit. As a result, the bulb will glow, and in here in the LCD it will display that light on, right? Light on, because light will be on at that time. If not, that means if it is greater than 500, the value of LDR is greater than 500, it is very bright outside. That means what? You have to put the value of relay to high. That means at that time your circuit will be open, and so bulb will be off. As a result, here also we will write light off. Okay, this is the program we have written. I have shared the link, okay, for this Tinkercad experiment. You can see, you can change the pins and you can check what is going on over here. Now if I run the program, you see what will happen. Okay, you see now it is turned out upside, right? So I will rotate it. Okay, don't worry, the connections are already done. Okay, just we are rotating now. Okay, you see now sensor value, you see it is 1017. That means it is very dark. So this is closed circuited, so bulb is on. As a result, here it is displayed light on. Now if there is brightness outside, that means value has come below 500. That means value of sensor is below 500. That means what? It is bright outside, right? So as a result, it will be open circuited. As a result, when it is open circuited, your bulb will be off. As a result, in LCD also it will be written light off. Okay, so this LCD is doing nothing but just reading the value of this LDR and giving the status of this bulb, either it is on or off. We'll check once again. You see now the value is greater than 500, so this bulb is on. As a result, it is written light on. So you try it. With this I conclude.